Okay, so what can I do with these two? What do I have to do now? Tell me this first. What's this times this? We'll leave this spot blank. That times that, I don't know yet. What else? How do I do these? This is really nice.
Y and a quarter to y to the fourth.
Yeah, it'd be fourth root of y to the fourth, which is awesome. Right? It's sort of like, what's this guy missing? Why am I not able to do that guy by himself? Exactly why am I not able to do fourth root of y cubed? Yeah, because the fourth root needs how many things inside? Freaking 4. It's only got 3. I love it. So what's this guy come and do? Here's one that you're missing. And why am I saying it like that? Because it's going to become important today when we do something called rationalizing the denominator. We're going to give it what it's missing. It's kind of nice. So that's what that does. And what is the fourth root of y to the fourth? Yeah, it would actually be absolute value y, but at some point they start saying in the instructions, assume all radicands inside isn't negative. Right? There's no part of it's negative. They just sort of say that, so it's like, good God, we understand the absolute value, but we got other shit to talk about. Don't worry about that for now. I can't remember. This is probably where they start saying that. Yeah. Assume that all variable expressions are positive, so you don't have to worry about the absolute value. But how the hell do I do this? Well, who remembers how you do it when the roots are not the same? What's the slightly better way to write a radical? What's another way to write a radical? Let's say it's the only other way we know how to write a radical. Fourth root of y is also y to the 1/4. It's 1/4 of y. If you missed yesterday, fractional powers relate to roots because fractions would cut things down, and that's exactly what roots do. These are actually the same. They represent the same thing, just two different ways to write it. And personally, I wish we just would have stopped here, to be honest. And when I do that times that, well, what's this? Y to the 1/9. And now you can make LCD.
Oh.
There you go. Cool. So if the roots are the same, you can just go ahead and combine and multiply the insides. No worries. The fourth root just becomes bigger and envelops both of them. Here they don't agree. They're not the same. What's going to grow bigger? Well, shit, we don't know. That's where you write it like this, so it makes a little more sense. Now it's an LCD instead of something weird. Right? It's just an LCD. Good old normal stuff. Cool. I like it. Anything else from homework stuff? Let's feel a little around. Through.
Can you do matrix? One example of matrix?
Sure. Yeah, once I teach matrices, I pretty much am doing one example every day, which I understand because there's a lot.
Because I get confused. I understand how to make zeros and ones, but I get confused of which one to use after I make one. 0, 1, 7, and then to make the other one 1, 0, 7, and to make the other one 0, 1, 5. I get confused like which one to use.
If you're like here, you mean?
No, before that.
Oh, okay.
Like, for example.
Okay, you mean?
5, 2, 5, minus 5, 5, 16.
Oh, yeah. 5,
2, 5.
5, 2,
5.
5.
Then on the bottom, minus 5, 5, 16.
Oh, so it's like just a system of two.
Yeah.
Okay. So
I did the first one. I divided by 5 to make 1.
Yeah, don't.
No.
I mean, you can. Let me get this straight. You can all day. Now, you guys think that I work with fractions pretty well. I'm not bragging. It's my one skill. So what the hell? I should be able to, right? I know math. Even me, I'm not going to freaking do that. I'm not going to make fractions because it's just easier to make a mistake. What can I say again?
5 minus 5.
Yeah, you can just add the two rows together. Now, your real question is, where do you put the answer?
Yeah, like and which one to use? Yeah. Like,
To be completely honest, you could put it either place. I mean, watch. If I do a lot of work and I end up here, let's say, am I wrong? No, I could just move that up there. Just really just move that up and move these down, right? If I wanted to make it officially. So I really want this understood. You can switch it rows.
it doesn't the computer say like you can flip them?
Yes, you can totally switch rows. So if you get a 1 to show up like here or here, it doesn't mean you're wrong. Just move that. Just switch those rows. You've got the one where you want it to be. And to be really honest, does it really, really matter that you have all these in the right order? No, I can tell y is 2, z is 7, x is 3. I can still read it. I can't just do 2, 7, 3. Because then I assume it's x, y, z. It's in order. Just don't do that, right? So there's more flexibility with this, but when you first want to get used to it, I try to make it a little more rigid so you can live within that and get used to how it works, and then you can start to realize how much more flexible it is. So here, yeah, I would definitely add them together.
So you get 0, 7, 21?
Yeah, 0, 7, 21. You can put that here, because that makes sense, and then you can leave the other one alone. But if for some reason you liked these numbers better, and here I don't, but if I liked them better, you can put the answer on top of this. You can overwrite this one instead. Right? You can lose whichever old equation you don't want anymore if you like the other one better. Because then if I did put the answer here, if I put it like this, 0, 7, 21, and I kept -5, 5, 16 for whatever reason, I could just flip those. Right? So that is why when I was doing this stuff, trying to show myself what I was doing, row 1 plus row 2, put the answer in row 2. That is a choice we make. It's a choice you make. I'm just saying you want to remind yourself later what choice you made when you want to go read this. There's no, why row 2? No, just because that's where I want the 0, no other reason. Does it have to be row 2? Nope, sure don't, because I could just switch them around and make it row 2. Right? And I understand when you first start to get used to matrices, you're not used to everything you're allowed to do. That's why I try to teach it very rigid at first, so you're not learning matrices and dealing with all this shit you're able to do at the same time. But the better you get at it, the more you can start to integrate more stuff you could do with them. Yeah. Hopefully that answers the question. But please, dear God, remember, 1s are great. 1s are awesome. But if I can't get a 1, I don't have to. So let me show you a quick example of what I mean. So what if I had, and this, hopefully you guys realize I'm just making this up out of nowhere, so the answer, who knows, might be kind of gross. What you got, Jeff? I don't know, Jeff. Let's say, it doesn't matter, 5, -7, and 3. All right, look at that yumminess. Oh, yummy. Now, I want to make 0 is my primary goal. So why is 1 kind of a secondary, kind of nice thing? Because they're the easiest things to make other zeros. Do you guys agree with me? If I see -2, now 1, I multiply by 2. Yay, it's easy. But here, can I make a 0 between these two? Yes, I can. If I multiply the top by 5 and the bottom one by -3. Do you guys see what I'm saying? So are 1s necessary? No, not to the very end. That's why I was like, you never have to make a 1 if it's going to make a bunch of fractions. Just don't make a 1. Right? So you could do this. You could say, negative, what do we say? 5 row 1 plus -3 row 2, and put the answer in row 2. So 5 times row 1, -3 times row 2, put the answer in row 2, I get 15 minus 15 is 0, 20 plus 21 is 41, that looks really promising, Jeff. -5, -9, ooh, that's going to be yummy. And then I still got 3, 4, -1. Do you guys see that? 0 is the goal. 1 is nice. 1's nice, makes it easy. But 0 is the goal. And now here I have to divide by 41. Oh well, you get some, Yeah.
Can we use the row 1 plus the 5 multiplied by 5 and negative 3? And can I put the answer on row 1?
Of course. Yeah. Yeah, of course. And you can keep this equation instead of keeping this equation. Of course. Yeah. Totally. I love it. Now, what would I do here? I would double this row, subtract that row, because then I could make a 1. You know, especially, not really, to be honest, with just a 2 by 2. But if I had like a 4 by 4 or something, and the 1 would, and I got a lot of shit below it to take care of. You understand? A 1 can kill this dude, can kill this dude, can kill this dude easy. So if I have a big matrix, I'm going to make a 1. I'm going to find a way to make a 1, because then I can use that 1 to kill everybody else really nice and quick. I don't have to bring fractions in. I don't have to constantly be doing this by 7 and this by negative 3 and this by 5 and this by negative 4. No, I want to make a 1 and just directly kill. Right? Do I have to do that? No, I can always do what we just did here if I can't make a 1 or can't see how to make a 1. Please let it make sense. That 0 is the ultimate goal, because of course what does 0 mean? That you killed that variable. Exactly. There's too many freaking variables. I think we can all agree in this section. It's X, Y, and Z, and Jeff's saying you could have a W or something for a fourth one. Right? Too many variables, kill some of them, dear God. So that's why 0 is the big goal. Okay, maybe. But, you know, the matrix idea is sort of like synthetic. It just sort of refocuses your attention on what's really important. Long division, there's so much shit that's not important. Synthetics just says, here's what's important. Matrix says, here's what's important. Zeros, ones would be nice, but zeros. Right? It just kind of makes us look at it a little differently. Okay, so anything else from homework stuff? Okay, all right. Okay. So, last time we actually got into 10.3 a little bit. So let's kind of review what happened yesterday. Oh, and just in case you weren't here, there's a quiz tomorrow. 9.1 and 9.2. And just to keep the party going, I'll make a quiz Thursday also. What the shit? 10.1 and 10.2. Alright. If you're smart, you know you want more and more and more grades. I had a class where the only grade was the oral final exam. Put us all in different rooms, gave us a problem, said, work on this, I'll be back. You don't want that shit. Trust me. Your whole grade riding on one. You want lots of grades. Okay. So there you go. You're welcome. So here's what happened in 10.1 and 10.2. 10.1 was really just the basics of radicals themselves. So for example, just to remind us, what's the fourth root of 81? Yeah, why is the answer 3? Yeah, exactly. It takes 4 3s to make 81. So I'm going to bring this back when we get there. I kind of brought this up, this idea of logarithms, and some people have heard of logarithms. You know horror stories about them. But it's all about understanding the question that the symbol represents. Who gives a crap that it's a log? It could be a little happy face. We just have to know, what is this symbol? What question does it represent? What does it take this many of to multiply to be this? That's the question it asks. If you know what question the symbol means, you know how to start working the problem. Is that simple? Math is shorthand, right? Court stenographers use shorthand so you can get everything down. It's just symbols that represent words so they can translate them later. Symbols that represent words. That's what math is. So 4 through 81 is 3. What about, what you got, Jeff? I don't know. 6th root of x12.
X2.
Yeah, x squared. And right? So you can either think, you know, what does it take 6 of to make x12? Well, it takes 6 groups of 2 x's to make 12, right? But here's the shortcut. What's the shortcut? 6 goes into 12 twice. Because now we also know from section 10.2, how would I rewrite this as a fractional exponent? 12 over 6, which is, yeah, exactly. That's why the shortcut works, because it is a fraction. I like it. I like it. Please love that shortcut. Love the hell out of the shortcut. So if I had 4th root of A12, B20, C44. Okay. So B to the 5th, C to the 11th. And officially, this is a 4th root. No. Since it's a 4th root, can the answer be negative? No. Can't be. Could this answer be negative? Yes. Why didn't I do that here? Can't be negative. We're assuming, we haven't even talked about them officially yet, so it can't be a complex number. Let's see. Complex numbers are numbers that when you square them, the answer could come out negative. That's the most fundamental property of complex numbers. I know. Somebody's like, what are you doing? Stop that. The funny thing about, no, screw it. We'll talk about it when we get there. I won't throw all that shit at you right now. Okay. So we got a connection between what this means and the fact that it cuts it down, and then you can write it as a fraction, which goes together. Fractions cut things down into size, and that's what roots do. So they're connected. Let's see. What are the big ideas? There's the idea of finding out the domain, which we actually talked about before. Right, so what would the domain of this be? Domain of this function. What you got, Jeff? Why?
It's their roots.
Yes, cool. It's an odd root. Odd roots can handle everything. What's even roots are the uptight ones. They can't. The answer can't be negative. They can't handle negatives inside. They're all odd roots all day long. They're fine. They can handle anything. So this would be all reals. Infinity. What about? So let's get down to brass tacks here. What about the 8th root of 7 minus 11x?
It can't be negative. So you have to make it 7 minus 11x greater than or equal.
Okay, beautiful. I love it. So when you said it can't be negative, you mean the inside. I love it. Whatever the hell's on the inside of an even root cannot be negative. So when we ask this question, what's the domain? It's assumed real numbers. If they wanted to include complex, they actually have to say it, and we haven't even talked about it yet officially. So to be real, this inside has to be non-negative, which means greater than or equal to 0. So again, every single time they ask you domain, you say in English, what must happen? And then you write that in Mathish. So remember, what was the other stuff that we did domains for? I mean, now you just solve this thing and it's easy, hopefully, right? So you get x less than or equal to. If I subtract 7, divide by negative 11, right? Is that cool? What was the other stuff we did domain for? Remember this kind of thing? How do you find the domain of this? Well, what's in English? What cannot happen? Yeah, the bottom can't be 0. There's in English what can happen. Bottom, 2x minus 5. Can't be not equal to 0. And then solve. People just sort of don't believe it's that simple. But anytime they ask you, what's the domain of this function? You say in English, what must happen? Bottom can't be 0. Write it in math. The inside has to be non-negative. Write it in math and then solve. It's crazy. It's beautiful. Right? English and math working together. It's crazy. Okay. Let's see. What else? Is there anything else from this? Oh, and then of course, since we can now write radicals as fractional exponents, they're going to just throw at you problems like this here. What you got, Jeff? I don't know, man. Sure, fine. I love it. Ooh, that's yep. Yep. All right, there's fractions in there. Who gives a shit? All right, what's the property? What inside? What can you do inside? What do you have to do?
Multiply with the negative 1. The x, no?
Do what?
Multiply, distribute to the x to the...
Oh no, yeah. Well, you could. You could bring the 2/5 in. Is that what you're saying?
Mm-hmm.
You could.
Just simplify the inside first.
But you could simplify the inside. Either one actually would work fine. But I just like to simplify inside before I start bringing something in. So what do you do with this? What are you doing here then?
Find the LCD.
LCD, because you have to add these, right? I like it. I like it. So when you raise something with a power to a power, you're going to multiply as if you brought the 2/5 in. Right? So what's the LCD here? 20. So you get x to the 15/20ths, and then minus 4/20ths. Whoop! All to the 2/5. So you get x to the 11/20ths. And of course, what do you do with those fractions? Multiply. That's what you do with these powers, right? So then I could just x to the 11/50ths. So it's just properties of powers, which you're supposed to know already. You're just having fractions in there. So if you have to add or subtract, get LCD. If you have multiply, you can reduce, all that kind of crap. Yep.
At the very first step, can I just multiply 3/4 by 2/5? Then
Yes, you
we
could.
do the same thing for the other x?
Yes. Like I said earlier, you could go this way. So what would what would happen there? This is one way to do it. So if you brought the 2/5 in, what would be x to the... Well, you can so let me put 2/5 here like this. Is that cool? So here that would be 3/10 times x to the negative 2/25. Is that cool? But now look at your LCD, right? It's a little bit worse. I mean, it's not that bad to be honest, but that's why I like to do the inside first, so that this guy doesn't come in and make my numbers big and gross. Now that's not that gross, but do you understand what the general reason why I do the inside first? This will still work. Is everybody cool with what just happened? When you raise something with a power to a power, you multiply the powers. Now I got to get an LCD. Of course, that's just going to be 50. So 3 times 5, 15/50ths, times x to the negative 4/50ths, which is x to the 11/50ths. Kick ass. Sweet. Okay, I like it. So yeah, there's always more than one way to do something. Yeah.
What's the domain on g of x?
That's the domain.
X less than...
Yeah. So if you wanted to, you can write it as negative infinity up to 7/11ths, inclusive.
So I don't understand. If we say like 7 minus 11x greater than or equals to 0, and then x is less than or equals to 7/11.
Did you try to solve this?
No.
Did you solve this?
No.
Well, okay.
If it's
What's up? So just solve it. Just solve it. I just did it real quick because I know you can. If you subtract 7 and then divide by negative 11, that's got to switch. You get x less than or equal to 7/11ths. That's all. You just got to solve it. I mean, you know, old shit that like that, I'm not going to show every step because I know you can do it. So if you're like, how the hell did you do that? Well, then you do it and you see how I did it. Yeah. Okay. Cool. All right. I think that's most everything from 10.1 and 10.2. You just got to get in there and try those suckers out. Blah, 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 blah. Oh, I guess, the last thing about fractional powers is how would I write this in radical notation, yeah, so remember, roots are on the bottom like most plants. Power's on the top. I love it. Cool. So, of course, I'm going to ask if you can go the other way. So if I had the third root of a plus b squared, yeah, a plus b to the 2/3. Okay, so that should be pretty straightforward. Especially because the root's on the bottom, it should be easy to remember. So the other one must be the power, right? I like it. I like it. So if I give you a number, though, there's a specific way I want to write this. So if I had 27 to the 2/3 power, how would I rewrite that so I can attack it?
Cube of 27 squared.
Yeah, cube root of 27, and I could put the square on the inside, but you see how that sucks? But thankfully, mathematically, I'm allowed to put it on the outside also. Because 1/3 times 2 is still 2/3. Right? Cube root of 27 is 3. 3 squared is 9. So the other way to look at it is 27 is 3 times 3 times 3. I want 2/3 of it, which is 9. Sweet. Okay. It's the same thing as 6 is 2 plus 2 plus 2. So 2/3 of 6 must be 2 plus 2 must be 4. It's the same idea. Okay. Okay, so that catches us up to 10-3. Blah, 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 blah. Ooh, yummy. All right. Oh, so I sort of got you ready for this section 10-3 and a few different things I've said. 10.3 expands what we're doing with these radicals. So, for example, the very first little piece they talk about here is related to a couple things. Let me see if I can get you guys. So we already talked about, didn't we talk about this idea, square root of, yeah, we did. We did this little thing yesterday about the handout, how to break radicals up. So just to remind you guys, if I had the square root of 27, I don't know what the hell that is. It's a little bit bigger than 5. Yeah, but you think about how could I break 27 up? I can't do the square root of the entire number 27. But I can do the square root of 9, which is a piece of 27. So you want to break that number up into a part you can do and a part you can't. And then crazy enough, you do the part you can do and you leave the part you can't. So square root of 9 is 3. And the square root of 3 is, I don't know, third base. No, let me just say Abbott Costello. All right, I'll be all right. So here's the first real application. It's related to, let's see, am I going to hell of myself? Oh, that's the next section. Oh, I hate the way they break these things up. So what about, okay, so here's the next level of this. Let me say it that way. The next level of this, now watch, this is kind of nifty. What's the 4th root of a to the 4th, assuming all variables are not negative, blah, 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 blah. So don't worry about the absolute value, right? What's the 4th root of a to the 4th? A. I love it. We're assuming it's positive. I like it. So what's kind of wrong, or why should I know that I can do something with this, but it's not going to be quite as pretty? It's sort of like, what's 4 divided by 4? That's crazy. And what's 5 divided by 4? Well, it's a little gross, but I can still do something with it. I can tear it apart into a thing I can do and a thing I can't do. Right? So I should be able to do the same thing. Like, it's really just like this. Isn't a to the 5th a to the 4th times a? So I'm going to do it this long way first to kind of mimic this. You can do it, Jeff. There it is. So a to the 5th is a to the 4th times a. Why did I break it up like that? Isn't it a squared times a cubed also? Well, that would be crazy because I can't do the fourth root of either one of those, right? What is the fourth root of a to the fourth? A. And what's the fourth root of a? I don't freaking know. But of course, if I have 5/4 of an a, that's a whole a, and 1/4 of an a. That's what that's saying. It's exactly the same thing. It's kind of crazy. So there is a shortcut, thank God. You got to love this. The way you've said it ever since you learned division is the way it applies directly. 4 goes into 5. 4 goes into 5 once with 1 left. Do you understand? Holy shit. So you've been getting ready for this ever since you first learned division. So let's do another one. Let's say the fifth root of b to the 12th. 5 goes into 12. Twice, so b squared with 2 left inside, right?
You can put the 2 inside because it's a variable rather than a real number. Or rather than an integer.
How do you mean you can put it inside?
So you can put it...
Oh, I see what you mean. The power?
Yeah.
Yeah. When it's a variable that I can't do anything with anyway, I go ahead and suck the power in because it's the most compact way to write it. Here, where did we have one a second ago? Shit. We bring the power outside because I can do something with what's left over, so I want it out of the way. So yeah, good. That's why I put that in there. Does that, you guys start to understand? So watch. Okay, here's the full problem. Here's what it's going to look like. Where'd it go? Oh, let's do the cube root of 16, a 11, b 32. Yeah, that's fine. Okay. So let me do this using the shortcut. But on that number, how am I going to apply the number? Numbers always seem to act differently than variables because variables are always written in factored form. Numbers are not. Do you guys see what I'm saying? I got 11 A's times 32 B's times 16. And 16 is hiding the fact that it's got 4 2's in it. So don't think that numbers, math treats numbers differently than variables. No, it treats everybody the same. It's just that these are not written in the same format. So now watch. Let me show you this. Let me just see if you guys get this. 16 is 2 to the 4th. Now watch. I can just use the shortcut. I can use the shortcut now on everybody because everybody's written the same way. 3 goes into 4 once with 1 left over. 3 goes into 11. 3 times with 2 left over. 3 goes into 32. 10 with 2 left over. So that, the number acts the same now because I wrote it in the same form. Now, how else can you do this problem? Well, you can split 16 up as 8 times 2. The cube root of 8 is 2, and the cube root of 2, I don't know. It would come out the exact same way. You just attack it in a different kind of way. Okay, maybe. You could also just do that with everybody. You could actually do this. Let me see. Sometimes people like this way. You could take this problem, write it as cube root of 8 times 2, A9, A2, B30, B2. You guys see what's driving me there? I want a number I can do the cube root of times something. A letter that has a number that can go into times whatever else is left. So forth, right? So I can see exactly who's going to be left inside. 2a squared, b squared. Bam. And then this is all the stuff that I can do something with. Cube root of 8 is 2. 3 goes into 9 3 times. 3 goes into 30 10 times. Right? Same mathematically, really, just looks a little different. Whichever way makes more sense. Okay, cool. Okay. Let me see, where else do you go? Blah, 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 blah. Yeah, same stuff. Oh, okay. Wow, this is kind of silly. I don't know why they put that in here, but oh well. How would you do... I don't know why they put this here, but they did. So too bad for us. Sure. All right. How do you mean solve each one? How do you mean?
Yeah, back to the top.
Yeah, okay. You can factor the top. So the top, how do you factor it? No.
Cancel.
Yes. Don't you have something similar? Not similar, but the same. You have a square root of x plus 4 and a square root of x plus 4. So those cancel, and what are you left with? Square root of x minus 9. Yeah. So that really could have been put in an earlier section. I don't know what it's doing in this section, but I won't. Yeah.
What happened to the negative 3b? How did you factor that?
No.
36.
Oh, I guess.
Yeah. That was a really lazy B if that was a B. Oh, you never know with me, I guess. I like it. You're sitting there like, okay, how's he going to do that? What the shit did he have? 4 and A? What the hell? Right. Man, could have been a doctor based on my writing alone. Blah, 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 blah. Okay, that's basically it for that. Let me give you one problem that shouldn't be a big deal. Let's see what you think. Oh, how did I write it? Write it the same way. Sure. Can you see what part of this problem is not going to work nicely? What part of this problem is easy? Come on now, which part of this problem is easy? What's the fourth root of x to the eighth? Yeah, cut it in 4 parts. You get x squared, don't you? So that's easy, x squared. Fourth root of y12? Y to the third. How the hell do you do fourth root of 32? Break it up, because you can't do it direct. Now, just to show you, 16 and 2, or to show you the other way, if you broke this all the way down, it would be 2 times 2 times 2 times 2 times 2. So there's 4 whats? 4 2's. So this would be 2, 4th root of, and this poor little dude is still stuck inside. So then you can put 2, 4th root of 2, bang. So you're going to have some of this stuff, mixtures of stuff that works really nicely, and then you just got to focus on the parts that don't. Right? Okay, I like it. So that's another section. Just get in there and try it. I don't know how else to feel out if you can do it or not. Okay, so here's the section I want to focus on today. Yeah, maybe we'll get into 10.6 a little bit eventually. So 10.4, there's some kind of weirdness. Oh, cool, okay. So I'm going to put up on the board a stunningly simple problem. And then I'm going to try to get you guys to realize it's the same idea as something that we see in 10.4. Let's see. What's 7a minus 2a? There you go. Everybody else is like something, some freaking little trap. It's all drop. So what is 7 fourth root of ym minus 2 fourth root of ym? Yeah, this is where people don't realize. I got 7 somethings I don't know minus 2 somethings I don't know is 5 somethings I don't know. So I got 5 somethings I don't know. It's just like terms. Slightly freaky thing possibly is it also works, you know, something like this. 4 square root of 2 plus 11 square root of 2 is 15 square root of 2. Square root of 2 is not a variable, but it's still something I can't do anything with. So I got 4 of these things I can't do something with, plus 11 more of the same thing I can't. So I get 15 things I can't do anything. Right, 15 of these things laying around. Cool. I like it. So here's where people get a little wonky. What if I had square root of 48 minus the square root of 27?
You break them down first.
Yes. If you are imagining the answer might be square root of 21, I want you to mentally take a little something to your brain and say, Bray, stop it, Bray. You can't do that. These are not like terms. You can only add and subtract like terms. These are not like terms. I can't do a square root across a subtraction. They don't play well with subtraction. I can't just rewrite this as the big ass square root of 48 minus 27. I can't do that. But square root of 48. Yeah, 16 times 3. 27. 9 times square root of 3. Yeah, so you get 4 square root of 3s minus 3 square root of 3s, which is 1 square root of 3. Bam! So unlike variables, so this is like 4x plus 11x. This is like x minus y. But unlike x minus y, these are numbers. Maybe I can do something with them. Whereas x, what can I do? I can like chop. I'll cut that off of you, and I'll cut that off of you, and I'll cut that off. Now your limbs are everywhere, x. What are you going to do now? Right? Maybe somebody's fantasized about killing the variables. Maybe not. I don't know. I watched too many horror movies. Go away. Okay. But these are numbers. I can actually do something with them. And maybe what's left over here will be like terms. Maybe. Okay, so what about this here? Cube root of 40 minus 3 cube root of 135. I like it. So now watch. What's really nice for these problems is there's a possible hint inside of them. That one should be easy. How am I going to break this one up? See, it always turns people off. He said it should be easy, you know, feel pressure. Yeah, 8 and 5. Why 8? Because 8 is cube rootable, right? So this would be cube root of 8 times cube root of 5. Now, if these have any hope of being like terms at the end, right? Because what's the cube root of 8? 2. What's cube root of 5? I don't know. Then what must go into 135 and leave something nice? 5 must go in, right? You guys see, that's a hint. And sure enough, 135 is 27 times 5. Right? And 27, now let's see, let me really make it clear what's going on. So I'm going to rewrite this. I have minus 3 times the cube root of 27 times the cube root of 5, because I just rewrote this as that. Is that cool? Because I always get a question about what do you do when there's a number out front already. Well, what is that number doing to this? Multiplying. Right. So you get 2 of these. What's the cube root of 27? Times 3? Yeah. So if something's out front already, it just multiplies with whatever else you manage to simplify. That's all. And now I got 2 of these minus 9 of these is -7 of these. Now, hopefully, obviously, if this would have been a 6 or something, like a 6 here, and that's a 5 there, you just stop. They're not like terms. Oh, well. You did everything you possibly could. They're not like, so you just stop. Yeah.
So it's okay to get a negative answer, right?
Of course it is. All day long. Totally. Don't overthink. Is the inside, and in fact, it's a cube root, so you wouldn't even be a problem. But if, if I can get a negative answer even if it's a square root, because the inside of the square root is not negative. There's a negative on the outside. So then the square root's not freaked out about that. Just can't handle a negative on the inside. I like it. Okay, cool. It's like a deer outside your house versus a deer inside your house. It's very different things there, right? One you can handle, the other one not so much. So I don't know. I don't want to make any judgments about you. You might have deer in your house. I don't know. All right, let's see what else they do in here. Blah, 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 blah. So that's one piece of this section is like creating your own like terms when they're not like by just simplifying the radicals, right? Another thing is this here. Let's see, where'd you go? Oh, that's crap. Get out of here. Oh, cool. Okay, good. I want to make sure it was in this section. This is something that we already did earlier. Let's see if you guys remember. So what if I have square root of 5 times the square root of 3 minus 4 square root of 7. Okay, now, I know there's radicals in this problem, but fundamentally, what property is this? I mean, what is this? What kind of problem is this? What do I need to do? Well, yeah, distribute, right? It's something times something in print. I got to distribute. What's square root of 5 times square root of 3? Square root of 15. Now here people get freaked out for some reason about the 4. Right? So we're not done with this. Let me show you a little side note here. They get freaked out, and I don't know why. What's this? xy plus 4x squared, right? Is that cool? What'd you do? X times x, of course, and it's still multiplied by 4, but there's 4 just comes, there's no number there to multiply 4 by. I multiply what I can together. So what do you do with the square root of 5 when you multiply it with the square root of 7? That's the one it can go with, right? It can't go with the 4. So just want to mitigate that. I always get, at least a few people are like, what do you do with a 4? Nothing. Just comes from the right. Minus 4 times square root of 35. Why do I not waste any time trying to break these down? They started broken down, didn't they? So I already know there's not 2 of anything in either one of them. It's 5 and a 7 and a 5 and a 3. I'm not going to waste time on that shit. Okay, maybe. I'm trying to get you ready to do this little handout that I got. One little note here. What is the square root of 7 times the square root of 7? Square root of 49, which is 7. So did I even have to say the square root of 49? No. Well, isn't this half of 7? Times half of 7 should make a whole freaking 7. I mean, that's right. Do you guys see that? Yeah. So what's the square root of 11.9 times the square root of 11.9? It's freaking 11.9. Don't waste time on 11.9 times 11.9. Oh my God. And then do the square root of that shit? No. Half of that times half of that makes a whole it. Right? So what about this one then? Sure. Yeah. So rad 2 times rad 2 is 2 times 5 is 10. Now you could write 5 square root of 4, but square root of 4 is 2 times 5 is 10. Right? That's fine, but I'm trying to get you guys used to Square root of something times square root of the same thing is that thing. It fills itself in. Aw, it's like a little broken heart thing. Yeah. And then what do you get here?
Minus 3 square root.
Yeah, minus 3 square root of 22. And then there's nothing you can do. I always feel really bad for the person that does this. What have they done wrong? Please don't write that. They've done a really bad thing. That was even worse than I intended. But what has happened here? What did they do? Yeah, these are not like terms. I have 10 ones, really, minus 3 of these. I can't put those together. Those are not like terms. It's like 10 minus 3x. Not like terms. Cool. Okay. All right, let's do this first, and then we'll talk about rationalizing the denominator.